Hello everyone and welcome back to Programming Chess with me. So in the last lesson I said that what we're going to be doing today is thinking about the special movements of the rook and the king, and then maybe going on to check. We are going to be doing that, but before we move on to that I would like to fix a few things up. For example, the bishop movement. Instead of saying all of this, we can just say change in y and change in x. So I was going to do it off camera, however I thought that I should probably explain how I'm going to do it. So now we have it set up as new column minus old column, being where change in y minus, so old y minus, or new y minus old y. So that's like the, let me actually get a screenshot here. I am just using Google Images. Yeah, credit source. Great. So for example, change in y, I'm talking about the columns. So if the change in y of the bishop divided by the change in x is 1, then that's fine. And because it's all absolute values, we can just compare it once to 1. Therefore, we can just completely remove the OR statement. And here, instead of having column, new column, etc., we can just have change in y divided by change in x. And what I mean by y and x are just like the coordinates, so hopefully you understood that earlier on. And that's always going to be true if the, well, if the movement is acceptable, this should be true. And so we've shortened the statement quite a lot now. And because we were using this for the queen as well, we can copy it over for the queen. This is all for the queen. There we go. That looks much cleaner. So for the rook, I think that we can also change it. So for the rook, what we can do is, if change in x is greater than 0 and change in y is equal to 0, or vice versa. So let's just put that in here. So if change in x equals 0 and change in y is greater than 0, meaning it's more than 0, so 1 or more, or the opposite of that. So I'm just going to copy and paste this and just change the letters here. That's x. We can also copy this over for the queen. Let me just find the queen again. Here we go. So this is all for the bishop. Now this is going to be from the rook, and that is also going to work. There we go. Now we don't have the odd lines going to the right. Good. Next thing. So now I think that is mainly done, but for shortening it, old code, I'm still going to keep that in there because I want to make sure that I have the logic just in case they need it for later on. And that's that. So now let's move on to the rook and the king. Similarly to how we were working with the pawn, we want to check, have a class variable called moves made in both of them. So this is the king, and this is the rook. At first, they're going to have no moves made because, well, you're just starting the game off. But when they do make a move, which is going to come under here, yes, good, just making sure, moves made plus equals 1. By plus equals I mean add 1 to moves made. Same thing with the rook over here. Good. I am going to indent this actually. Or no, that shouldn't be indented. That should be control. Again, not what I meant to do. I meant to do shift end. So shift end selects the whole line. For any of you unfamiliar. There are some good shortcuts for programming. So that's now we've added moves made. So the only time that you can do when you can castle is if the king and the rook haven't been moved at all this game, and if there is space in between them. We can do the checking for pieces in between them later on, just like we're going to do the diagonal enemy checking later on. But for now, we just want to make sure that if the player wants to castle, they can, basically. So we want to count it as a valid move. So we want to add another OR over here. OR. So we are working in the rook now. So if, well, actually for the rook, this won't matter because it's going to be moving to the left or to the right anyway, and it's not going to be moving up and down at the same time. So we don't actually need to count this for the rook. All we will need to count for the rook is moves made and make sure that it's 0. And then we have the king, which checks movement here, or there we go. And we want to see, so the king can move more than one space as long as the rook hasn't been moved to the rook in that direction hasn't been moved. So let's take a look at this board. Let's assume that the queen, the bishop, and the knight are gone from the left. So, and that the castle and the king haven't not been moved this game yet. What the king can do in that situation is move right up to the castle, so where the knight would have been, and then the castle would move over the king. So it would be on C. So how would we check that? The same thing applies for the black king, so he would move 3 to the left. So we can check if the change in, well, we don't exactly want to do change in this time. So we want to check whether the movement to the left of 3 or movement to the right of 2 is applicable or a legal move according to how many moves they have made, or the king and the rook have made. So for now, I'm just going to call the rook and the king king. Even though there are 2 rooks, I'm just going to refer to them as rook for now. We can think about that later on, perhaps while we're actually programming, because this is pseudocode again. So this is the king's method. Or, so we want to see change in X. So if column number is changed by 3, I believe. So 1, 2, 3. Or moves made is 0, and change in Y is 0 as well, because we don't want the king to be moving up or down, as well as change in X is 2 or 3. Now, as I said, I don't want to call it change in X because it's dependent on which side you want to move the king to, which is why I'm going to call it column number like I did before, or col num. And col num equals -3, or col num equals 2 or +2. If we're counting from right to left, then that would be taking away things, and from left to right, then we would be adding things, which is why this would be a +2, but that's implied, and here it would be a -3. The same thing applies for the black king, because the kings are on the same column, and so are the queens, and so on. So this is how I'm going to be doing this. So new col num, I guess, here, new col num, and new col num. So that's how I would be calling up a castle position, in which case the king would be moved to there, so they would be allowed to move to there, and at the same time I would make sure that the rook is also moved over the king. So that's one of the special conditions covered, and I believe that that's the last piece special condition that we can cover. The next special condition we can work on is check. So what happens when your king is under attack? So for now we're not going to worry about taking out the piece that's attacking the king or protecting the king, but what we are going to worry about is how the pieces are going to behave in this situation. So we've already got this function called check condition of board, which would return check, checkmate, or stalemate after a move has been made. And it checks the condition of the board after each time. Actually, it would return those three along with normal. So what we do want to check is these conditions, well, the way that the pieces behave only behave under normal conditions. So under stalemate, under checkmate, or under check, they wouldn't behave in the way that they do right now. So we also want to check, therefore, that the conditions of the board are normal. How we do that? Well, it's quite easy actually. We just go through each of the check valid move methods for all of the pieces, and we just add and check condition of board equals normal, and we just add that into all of them. I'm just going to do this off camera, seeing as it's probably quite boring to watch. So now I've put that in. However, we also need to think about which one takes precedence. I'm not sure how that word's pronounced, but you know what I mean. So not is evaluated first, then and finally or. However, we want and to be evaluated finally. So that means that in our actual program we will want to put parentheses around everything except the very last and. So there we go. The and is going to be evaluated last, because parentheses always work out first, just like in normal maths. I'm going to just repeat that for the rest of the functions. So now that's actually a lot of the logic of chess done. The next thing we would have to do is how pieces interact with each other, how they're taken out. But for that, I think that I am going to start actually writing the program somewhere. So I would like you to please tell me whether you would like to see this in Python or in Unity. I am going to limit it to those two choices. Personally, I would like to do it in Unity so that it's more visual, we can see what's going on much more easily. Drawing won't be too difficult, I can just use some non-copyrighted images or something, or draw them myself. The pieces shouldn't be that difficult to draw either. I can just put a cave in the worst case scenario and just make an 8x8 grid, which won't be that difficult either. So that's going to be it for today's lesson as well. Seeing as the previous lesson was slightly longer, this one might come out slightly shorter, but hopefully you guys don't mind that. So until next time, in which when we are going to be programming in C#, I think that was Unity. Let's just take a quick look. What language is Unity programmed in? I believe it's C#. C#. So you can program it in, it supports Unity script, which is similar to JavaScript and ActionScript. We've done JavaScript programming. C#, similar to Java. We have done Java programming as well. C#, I've done some C# programming myself, and Boo, which is similar to Python, so maybe we can actually include Python in it as well, so we will have to see. Because I'm not that experienced in using Unity, I just know that it exists and I have it downloaded and installed and ready to go for when I do want to use it. But yeah, until then, please tell me what you would like to see in the comments down below. There should be enough time. And yeah, if you like this video, please give me a like, share and subscribe. It helps me out and encourages me to make more videos such as this. Until next time, thank you so much for watching once more, and goodbye.